I am Milind Oak, Senior Redshift Specialist Solutions Architect, and I am joined by my colleague Rex Khare, who will be taking this session on RDS MySQL zero-ETL integration with Amazon Redshift. A common pattern we see with customers is using Amazon Aurora or Amazon RDS for their operational databases and Amazon Redshift as their analytic system that powers insight. Typically, customers have multiple Aurora and or RDS databases, and so it requires them to build multiple data pipelines to get their operational data ingested into Amazon Redshift data warehouse. And we have heard that ETL is the biggest cost in their setups. And in order to make it easy to replicate this data from Aurora RDS databases to Amazon Redshift, we embarked on the zero ETL integrations with Amazon Redshift. Zero ETL eliminates the need for customers to build and manage complex ETL pipelines and yet get near real time analytics on petabytes of transactional data. This journey began with Redshift Spectrum, which provided the ability to query data in place, for example, from your Amazon S3 location in open file formats and popular table formats. Then we added federated query, which added access to transactional data residing in external databases in Amazon RDS for PostgreSQL, Amazon Aurora PostgreSQL Compatible Edition, Amazon RDS for MySQL, and Amazon Aurora MySQL Compatible Edition, and enabled direct access from Amazon Redshift. Then, Amazon Redshift Machine Learning further eliminated the need for data movement, and you are now able to build and run inferences directly from Amazon Redshift by leveraging the Amazon SageMaker integration. Redshift data sharing was a major milestone as it allows access to transactionally consistent data in place without moving or copying data. And the AWS Data Exchange leveraged this data sharing technology, which enables you to monetize your data as a product via the AWS Marketplace. The streaming ingestion in Amazon Redshift makes data available for analytics faster, leveraging materialized views on top of Amazon managed Kafka and Kinesis streams. With Amazon S3 autocopy, you can now set up continuous file ingestion from your Amazon S3, which automatically loads new files without the need for additional tools or custom solutions. And finally, the zero ETL integration, which enables near real time replication of transactional data to Amazon Aurora MySQL, which is in GA already, and Aurora PostgreSQL and RDS for MySQL, which is in preview, and also DynamoDB, which is in limited preview. Amazon RDS MySQL integration enables Amazon RDS MySQL customers to run near real time analytics and machine learning on petabytes of transactional data by offering a fully managed solution for making the transactional data available in Amazon Redshift within seconds of being written into the Amazon RDS MySQL instance. Customers simply choose the Amazon RDS MySQL databases containing the data they want to analyze with Amazon Redshift, and the schema and data will be replicated into Amazon Redshift automatically. This eliminates the need for customers to build and manage complex data pipelines and allows them to instead focus on improving their analytical applications. Customers can replicate data from multiple Amazon RDS MySQL database clusters into the same Amazon Redshift instance to derive holistic insights across several applications while also consolidating their core analytical assets, gaining significant cost savings and operational efficiencies. The zero-ETL integration operates via the RDS MySQL binary log, also known as the bin log. This process works by collecting changes to the database logs using the database engine's native API. It adapts to the RDS MySQL side schema changes, and you can monitor progress, lag, and performance from Redshift system tables and also CloudWatch metrics. Consider this solution architecture where you have streaming data, for example, codes or tick data, getting ingested via the Amazon Redshift streaming ingestion capabilities. The transactional data, for example, trades being executed, gets ingested via the zero-ETL integration in near real time into Amazon Redshift. And finally, the third party data, for example, market data like sector, industry, or security master, is being procured via the AWS Data Exchange and is directly available in Amazon Redshift as tables without needing to ingest it via files. The analytical data warehouse, which runs on Amazon Redshift and powers both internal reporting, leveraging QuickSight, and also near real time trade dashboard, which is built using your favorite dashboarding tool. Let's look at the steps involved for this setup. These 5 steps, they can be also done automatically by the zero ETL wizard, but that might require a restart. So you could choose to do these steps manually and then perform the restart at your convenience. Let's look at the demo now to see how easy it is to perform this zero ETL setup.
Thank you, Milind. Hi, everyone. I am Rax Khare, Redshift Specialist Solutions Architect. Let's log into our AWS Management Console and get started with the demo. We will configure Amazon RDS as the source and Amazon Redshift as the target. Let's navigate to Amazon RDS console page and configure RDS MySQL as the source. To create an RDS for MySQL database, we will create a DB parameter group first. Navigate to Parameter Groups and click on Create Parameter Group. Select parameter group family as MySQL 8.0. We will keep type as DB parameter group. Let's call the DB parameter group as zero-ETL custom PG demo. And let's provide a description here and click create. Our parameter group got created successfully. Verify the parameter group family to be MySQL 8.0. Open the parameter group and click on edit. Zero-ETL integration works by using binary logs, bin log, generated by MySQL database. To enable bin logs on RDS for MySQL, there are 3 parameters that must be enabled. First, the bin log format should be set to row. Bin log raw image should be equal to full. And third, bin log checksum should be set as none. In addition, ensure that bin log row value option is not set to partial JSON. By default, this parameter is not set. Let's save changes. Now choose Databases in the navigation pane and click on Create Database. The engine type should be MySQL. From the engine version, choose RDS for MySQL 8.0.28 or higher. I will choose MySQL 8.0.36 for this demo. For templates, select Production. Multi-AZ DB cluster is not currently supported, so we will either choose a multi-AZ DB instance or a single DB instance. For this demo, I will choose multi-AZ DB instance. For DB instance identifier, I'll type in zero-ETL source RDS demo. I'll provide a master username and password. Under instance configuration, You can choose your desired DB instance class. For this demo, I will choose a standard class of size db.m5.large. Configure appropriate network connectivity and monitoring settings. Once finished, expand additional configuration. Under DB parameter group, choose the parameter group you created earlier, zero-ETL custom PG demo. And finally, click on create database. In a couple of minutes, it should spin up RDS for MySQL database as the source for zero-ETL integration. While it's creating, let's create and configure Redshift. In Redshift console page, we will create Redshift data warehouse as a target for zero-ETL integration. The data warehouse must meet the following requirements. It should be using an RA3 node types, RA3 16XL, RA3 4XL, or RA3 XL Plus, or Redshift serverless. Redshift should also be encrypted if you are using a provisioned cluster. For our demo, we will create a Redshift serverless workgroup. As RDS MySQL zero-ETL integration with Redshift is in preview, so we will create Redshift serverless in preview track as well by clicking on Create Preview Workgroup from the top banner. Let's provide a workgroup name, zero-ETL demo workgroup. You can choose from the performance and the cost control. I will keep it the default settings. Then I will configure the network and the security and click on next. We will be creating a new namespace. Let's name it as zero-ETL demo namespace. We will provide a custom admin username and password. And click on next. Let's review the changes and click on create Redshift serverless workgroup. This will take a couple of minutes for Redshift serverless to get created. Meanwhile, let's navigate back to our RDS console and see if RDS MySQL database has finished creation. So the database is in the available state. Now that our source and target resources have been provisioned, to create a zero-ETL integration between them, a user or a role must have appropriate IAM permissions assigned. At minimum, you need permissions to perform the following actions. Create zero-ETL integrations for the source RDS database, view and delete all zero-ETL integrations, and create inbound integrations into the target data warehouse. A sample policy has been provided in the zero-ETL integration document, and you can find the link in the description of this video. After the appropriate IAM policy has been assigned to a user or a role, let's start creating our first zero-ETL integration from Amazon RDS MySQL database source to Amazon Redshift target. On the Amazon RDS console, choose zero-ETL integration in the navigation pane. Choose Create Zero-ETL Integration. For integration identifier, enter a name. For example, zero-ETL demo. For source database, click on Browse RDS databases. RDS automatically filters to supported engine versions. In this case, choose the source cluster zero-ETL source RDS demo that we created earlier. Next, we will select the target Redshift data warehouse. We can choose a data warehouse in our current AWS account or in a different account. To specify a different account, we would simply enter the database ARN. In this case, we will choose an existing data warehouse in our current account. Click on Browse Redshift Data Warehouses and choose the Redshift Data Warehouse zero-ETL demo namespace that we created earlier. RDS will automatically validate the parameter settings for the target database. In this case, our data warehouse does not have the correct resource policy and case sensitivity parameter to support zero-ETL integration. We will have RDS fix this for us. Next, you can review the changes RDS will perform on Redshift. In this case, it will update Redshift target resource policy to have authorized principal and integration source. and enable case sensitivity for Redshift. Click on Continue. RDS is now fixing the parameter values. We can view more details from the progress bar at the top of the page. RDS is modifying the case sensitivity parameter on workgroup, and it will then update the resource policy. RDS has successfully fixed the case sensitivity parameter and the resource policy for data warehouse zero-ETL demo namespace. Now, optionally, we can add tags and customize the encryption settings. We will skip this step. Let's review the settings and create the zero-ETL integration by clicking on Create Zero-ETL Integration button. It can take up to 30 minutes to create the integration and change status from creating to active. This time will vary depending on size of your data set in the source. Let's fast forward to when it has been successfully created. The zero-ETL integration has been successfully created for Amazon RDS MySQL database zero-ETL source RDS demo. We can see it that it is now in the active state. The last step is to create a database in Redshift that is linked to this integration. To do this, we will navigate to Amazon Redshift Serverless console. Next, we will go to our namespace, zero-ETL demo namespace, and open the details for the integration which we have created by clicking on zero-ETL integrations. We will now create a database from integration. Let's name it as demo DB and click on create database. The database has been created. Now data written to our source RDS MySQL database will be replicated to our Redshift database. Now we will populate the RDS MySQL source database with sample data and analyze the same data in near real time in Redshift Target. Let's connect to RDS MySQL source using command line. You can either use an existing database or create a new one for this demo. In this case, we will create a new database called zero-ETL DB. We will then create a new table called sales in this newly created database zero-ETL DB. We will load some data to the sales table from a local file. Let's validate if the data has been successfully loaded to the sales table. We can see that there are some records in this newly created sales table in zero-ETL DB database of RDS MySQL. Now, let's analyze this data in Redshift. On the Redshift console, open Query Editor v2 and connect to the workgroup which we have recently created. You can use the following code to validate the zero-ETL integration seed or CDC activity. We can see that there are few most recent CDC event which is due to the new database which we have created and a new sales table that we have created few seconds back in RDS MySQL and populated with data. We can also verify by expanding the catalog and see newly created sales table within the zero-ETL DB schema of Redshift database demo DB. Let's query this table. And let's validate the row count in this table. We can see that the row count in this table matches with the row count of that same table in RDS. So that is it. With just few clicks from the UI, we have seen how easy it is to create a zero-ETL integration from RDS MySQL source to Redshift Target without any need to create and maintain a complex pipeline. Redshift also provides certain system views and tables to easily monitor zero-ETL integrations within Redshift. SVV integration view provides you configuration details around zero-ETL integration. Sys integration activity provides information about completed integration runs. And you can see that when you first create the integration, it will seed the data from RDS MySQL to Redshift, and from then on, it will continue to do a CDC. And then finally, SVV integration table state provides table level integration details. In this case, we have replicated a sales table from RDS MySQL to Redshift, and the table state shows as synced. In addition, you can also view integration related metrics published to Amazon CloudWatch. Let's navigate back to Amazon Redshift console, choose zero-ETL integration from left navigation pane, and click on the integration link to display activity metrics. You can see the integration metrics and table statistics. These metrics will be populated as soon as data starts flowing. Integration metrics contain table replication success, failure, counts, and lag details. In addition, table statistics contain currently active or failed table level replication details. And that is it. In this demo, we showed you how to set up a zero-ETL integration from Amazon RDS for MySQL compatible edition to Amazon Redshift. This minimizes the need to maintain complex data pipelines and enables near real-time analytics on transactional and operational data. Thank you for watching.